Hello. Good evening, everybody. Thank you for coming. I'll just say a few words and then I'll hand it over to David from Codon Consulting. So if you haven't been to these events before, this is Stockholm AI. It's a non-profit organization. We run these meetup events regularly so that we can spread the knowledge and everyone can be better for it. Yeah, you can be part of this community yourself, so you just join for free. If you go to stockholm.ai, you can join. Doesn't cost you anything. We have a Slack community as well where we share a lot of information, and yeah, typically you get sort of a first early invites to these sort of events. And we have a few sponsors, so all of this is free. Like, you didn't have to pay to come here, and all the food is free, and that is thanks to a couple of sponsors that we have. We have Televox, and we have an upcoming sponsor called Inside Genie. And we also have EQT as a venue partner. So you have these beautiful premises here with a lovely view. And that's thanks to EQT for hosting us. But I won't take any more of your time. So what I'll do is I'll just hand it over to David, and he'll say a few words and then take it from there. Thank you.
Cheers, Armin. All right, one sec. Okay, yes, I don't know why I'm getting this echo. I don't know, you're supposed to be able to see the screen. Classic technical difficulties. Wonderful, thank you. Okay, my name is David. I'm a AI business developer at Codon Consulting. I'm just going to do a very quick intro before I pass it over to my colleagues Mikael and Linus. Yeah, so we started in 2019. We've been involved in over 50 different AI projects, communicating with hundreds of different stakeholders across many different domains. And our focus is always on clear business value. Yeah, you can see some of the clients we've worked with here. We're one of the leading AI consultancies in Sweden. And the past year has been very busy for us. One thing I can point out is that we've recently become a partner with Siemens with industrial edge and IT/OT connectivity. But what we do and how we work, we provide tailored AI and data solutions, end-to-end capabilities, so basically anything data, machine learning, and we provide complete and robust solutions across many different domains. Here's a brief view of how we like to work, which is based on agile. So we like to innovate within the restrictions and requirements of the companies that we work with. And yeah, this is our process, which has been developed over the years that we've worked. Yeah, working agile within the restrictions that exist and the processes that exist within companies. So why speak with us? We've got a deep understanding of the real estate and property management. We like to think that we can speak your language and understand your challenges. Mikael and Linus are going to go through a few case studies that prove this a little bit more. We've got a proven track record with industry leaders, and we don't just provide AI. We understand your domain, and AI is only useful if it's solving a problem and providing a solution. But before I pass it over, yeah, we're here. There's a few representatives from Codon here. If you can raise your hands. So yeah, feel free to chat with any of us at any point. It would be great to get some meetings with some of the people in the room. And yeah, for all the students here, we're hiring, and we're always on the lookout for new talent and engaged and ambitious data students. So thank you very much. I'm going to pass it over to Mikael and Linus now.
Is this turned on now? Yes. Hello, everyone. I'm Linus. I'm a machine learning engineer at Codon, a data engineer. And with me today I have Mikael Huss, who's the co-founder of Codon and a senior data scientist. And today we're going to listen to the property perspective. That's from Fabege. That's one of the speakers. And we have Myrspoven, who's a product around property technology. And then we have us two. We are consultants at Fabege. So we started our prop tech journey with a simple question 2 years ago. What can you do as a data scientist, analyst, at a property management company? And we found some, shall we call them low-hanging fruits when it comes to AI and like data sciencey things. We have something called document understanding that involves like pure digitalization, improved search, semantic search, like that's in the call right now. It's a bit hyped. RAG, things like that. Microsoft Copilot. We have experimented with room occupancy estimation that we're going to go in depth with soon. Another thing when it comes to properties are energy. They're very energy consuming, so we want to optimize that for forecasting and prognosis, much more. We also have budgeting and CSRD. What was that now again?
Yeah, Corporate Sustainability Reporting Directive, I think.
Exactly. Good. So that concerns new legislations from EU, right? With sustainability reporting, that's coming an increasingly big part of companies' costs to report it accurately. We haven't really delved into that, so we're going to leave it down there. When it comes to like what you can do with AI in properties, maintenance is a really interesting thing. We can do anomaly detection and find problems early on. We're going to talk more about that too. And also property usage. Here we can do like customer-facing dashboards. We can do in-depth understanding of how are the spaces utilized, and not just the offices, but like bicycle rooms. How are people charging their cars? Should we build more car chargers, more bicycle rooms, etc.? And at the first glance, this seems kind of easy. Like we have Azure, and we have some visuals in Grafana, but property, it's quite advanced, and they have accumulated a lot of systems, like both within the properties and also digital systems over the years. So this is my data iceberg picture that like we have the staging environments like Sandbox, and then we have to test it and put it in production. We have different like partners of Fabege, Omega Point, a place called Hub, and IT Total. And then we have like in the hidden area, we have even more partners, even more systems, like a data layer from the 90s. And all of this has to come together to make nice AI features and help Fabege understand their business better. So with that said, I'm going to let Mikael introduce 2 use cases, starting with meeting room analytics.
Yes, thank you, Linus. There is a lot lurking underneath the iceberg, the data iceberg. But let's peek into the meeting rooms. So why is it interesting with meeting room analytics? So it's actually a bigger thing than you might expect. A lot of companies are thinking about this type of thing, and some people are, or some whole companies are working full time with understanding how meeting rooms are being used and how they should be designed. And right now it's especially topical because During COVID, obviously, everyone learned to work from home and take meetings from home. And then when it sort of died down, a lot of people thought it was kind of nice to stay and not go back to the office. Many employers want them to come back to the office, but it can be difficult, and then they face a choice. Should they repurpose these meeting rooms, turn them into something else, or what should they do? So there is actually quite a lot of interest and money in this, and it's also something that Fabege might want to offer to their own tenants as a service. So we then built a prediction model for meeting room occupancy, looking specifically at meeting rooms. For starters, then we're going to aim higher, of course, but we start with this. And when you build a model, you try to approximate some value with the function, right? So you have some input variables and you have a target variable. The input in this case is a timestamp. We want to know, or we know the occupancy at some specific time. We also have some sensor data, maybe other data. And then we have an output that we want to model. So in our case, we use just the number of people that are in the room. It could also be binary, like is the room occupied or not, but that's a bit too easy, right? So we try to do it as a count. And yeah, you might think that you could use cameras for this, but of course this is very problematic from a privacy viewpoint. So yeah, we don't use cameras. Instead, we use indoor climate data, carbon dioxide levels from sensors that happen to be in those rooms, and the temperature in the room, and some air flux measurements. And to know how many that were in the room during the training data period, you can think about different ways to do it. And calendar bookings is something that comes to mind, but that's very unreliable because yeah, you don't know how many are actually connecting remote. If 8 people said yes, and 3 are in the room and 5 are remote, for instance. Some studies have used Wi-Fi connections, but that's not something that Fabege is tracking. It's also a bit sensitive. Motion sensors is something that we did use for a while. Motion sensors attached to desks that give a signal when there's motion in the vicinity. It gave pretty noisy data. So in the end, the most reliable way is to just walk around and count. And there is this nice app called Vantage Space, which I use to walk around every hour in the office and register how many people were in each meeting room. So that's one way, although it takes some time. And having these input and output variables, we can build a model. Of course, we use XGBoost, the greatest prediction algorithm of all time. And with that, we can produce, for instance, this kind of heat map that shows a prediction of how much a certain room was used during a period of time. So for instance, you can see that this meeting room was occupied a lot after lunch and not so occupied at all on the Friday. I think the Thursday on this week was a holiday, so it's not in this heat map. Yeah, we built dynamic dashboards to show this kind of heat maps for each room, and that's also something that tenants could get. Let's move to the second one. And am I doing okay on time? Where is Armin? Yeah. So the second use case we will discuss is about district heating. It's fjärrvärme in Swedish, if you're more familiar with that. And yeah, it's basically just that you have a central a system where you transfer heat to different properties, residential or commercial properties, in a centralized way, which makes it more efficient. And yeah, some things to consider here are, I mean, of course, this is mostly interesting during cold weather, I mean, obviously, but also that when it's very cold, it gets very expensive. So it's not really a linear relationship. And of course, you have various components that can break in such a system. And we got asked to build a prognosis model for district heating, energy and power usage. So power is energy per time. And those are both, like the way you pay for this is based on both of those. There is like a complicated formula that considers different time periods and the energy and the power. But why do you then want to predict how much you will need? There are several different reasons, and sometimes the contracts are written so that you have a limit of usage, a power limit, for instance, that you cannot exceed in a single hour without a financial penalty. And if you have a prognosis that can warn you a couple of days or a day in advance, you can take measures to avoid those penalties by starting to heat the building a bit earlier, for instance. And you can also use this prognosis as a kind of anomaly detection. If you see that the prognosis or the behavior of the building starts to deviate from the prognosis, so it's not behaving as before, then there could be some issue with the building, and then you can come in early and fix the problem and save money in that way. And just in general, like it's good to have a handle on your consumption profile. How much are we actually paying for this? Budgeting, how much will this cost in the coming months? Should we change our contract? Sometimes there are ways to negotiate the contract with the energy supplier. So there are many reasons. Yeah, so this is what our prognosis tool looks like. I hope everyone can see it. I'll try to go through what this actually shows. So there are 3 panels. If we look at the upper panel, the orange line is showing the actual consumption, kilowatt hours, and like the measurements have been collected here. So after that, it's just going to 0 because it's just doing prediction a couple of days into the future. So this is the historically measured energy from the past couple of days, and the dotted yellow line is the prognosis. So the prognosis is following quite well, and here you see what it prognosticates for the next couple of days. The blue line is the limit that you can use in a day. the middle panel is an hourly prognosis, so it's looking more at the, not exactly momentaneous, but like a shorter time span. And again, the orange line is the power in kilowatts, and here there are actually two prognosis lines. It's it was two different models that we were comparing, and the data has been collected up to here. So from here, you see the prognosis for each hour for the next couple of days again. And as you can see, it's generally quite good. I mean, you'll never get it exactly right because of fluctuations, but the general shape is pretty good. The third panel is measured temperatures at weather station in Stockholm, and also what the temperature prognosis was. I don't know if it's 1 or 2 days before the measurement, because when we use this in practice, of course, we don't know the temperature. We have to use the prognosis for the temperature as well. So it's useful to see how good or bad the temperature prognosis is. I can go back again. So up here there are some menus where the technicians who look at these models, where they can select one of the 44 properties that have this kind of prognosis model. So we've got a model for each property. I mean, I could go down in detail on how the models are trained, but it involves CatBoost, so I put that logo here. It's a bit more complicated than that, but that's one of the components. And we have an MLOps system where this just run automatically. So every week the models are retrained on including the new fresh data. And if we get a model that is obviously better than the old version for one of the 44 properties, it substitutes the old one. All of this, both the retraining and the inference, which is when we actually produce the prognosis, are GitHub actions that are running on a schedule. And the models, both the ones that are actually used and the old best models that we store are stored in an Amazon S3 bucket. And also all of the metrics, the error measures that we use. Then we have set up automated alerts using emails through Databricks with detected anomalies. If a property is deviating too much from its prognosis, then the, let's say, master technician gets an email, and then he can let someone go and have a look at that property. And currently we are migrating all of this to Microsoft Fabric. So that's a lot of fun as well. Okay, so what value does this deliver? Well, as I maybe mentioned before, it warns technicians about upcoming high-cost days and hours. And then they can be a bit prepared and preheat, for instance. But also through these anomaly alert emails, you can see if a property is not behaving properly. And that happened this January. A property in the city had a very large prediction error. And when they went there to check, it turned out there was a faulty cooling system that was blasting out cold air, which is not what you want in January. So a lot of heat was generated to compensate for that. And it had a very high energy consumption. And they were able to fix that problem very quickly. In terms of monetary value, before this project had started for real, one of the energy experts at Fabege estimated that it could save around 2 million crowns per year. We're still in the first winter when this is being used, so obviously we don't know what will happen, but it will be interesting to see what the monetary gain turned out to be. So that's that, and some things that we have in the pipeline that we are in some cases working on, and in some cases almost working on, is doing the same thing for district cooling, which will be, of course, rolled out a bit later, maybe May or something like that, because it's only relevant for the summer. And then, very importantly, extending this idea of anomaly detection to many other systems. We've already looked at ventilation, HVAC, the ventilation systems a bit. Water and different types of energy consumption. And we are also quite excited to get started with automatic document reading. As Linus mentioned, sustainability reporting is becoming really big. It's required for companies over a certain size, 200 or 300 or something, and everyone needs to do it now, and it's often a lot of emails and Excel sheets and PDFs that need to be parsed, and the data needs to be compiled. So that should be a lot of fun as well. That's it for us.
Thank you. Very nice. I've got a mic here, so if you have any questions, just put your hand up and I'll run with the mic. There's one all the way in the back there. Oh, my.
Yeah, I have a quick question. One of the metrics showed the holidays in Sweden. I wonder, do you feed the model the calendar, so it can predict better if it's röd dag, if it's a holiday or something?
Are you talking about the first or?
No, it was in the, I think, the first one. And
yeah,
the
first
during
one.
the holiday. I just wondered, do you feed the model the Swedish calendar so it can predict better if it's probably not going to be people or need heats to the buildings?
Actually not for that model, but it would be a very valid addition.
Yeah, it would be.
We looked into it, but we never implemented it.
Yes, I think I've done traffic forecasting in the past, and I've had this where I put in the date and the day of the week and the week number as well, and the model was actually able to just follow that. So it wasn't actually predicting the real traffic. It was just essentially fitting to the day. So it might be interesting to, look into that as well. Maybe, I don't know, take it out or compensate for it in some way. Any other questions? Yep.
I'm curious if you had the data available to you already, ready to use, ready to parse, ready to process, or how much effort was it to collect it? Were they already collecting and storing it? I know you showed something on the iceberg in the beginning, but was that already available, or do you have to say, hey, actually, let's record all of this and keep it available? How was the state?
Yeah, very good question. So in the first case, let's see. Yeah, the indoor climate data was available, but it took some work to extract it from the system, like export it to CSVs. So it was there. The ground truth, we used some different ground truths, as I talked about a bit. So there were these motion sensors, but that data was just events. It's just like an event stream with a timestamp. So we had to come up with some way to turn that into a ground truth. Like, yeah, during this 10-minute period, there were about 3 people in this room. So that took some work. And then I collected some data by just walking around with an app. And finally, there was also an estimate in the system that collected the carbon dioxide data. So they also had an internal estimate, which we don't know how it was computed, like a black box.
Yeah.
So, yeah.
So now we're working on centralizing the data storage from all these different streams.
The CO2, for example, was it already stored the previous days, or was it just available and then you were storing it during the experiment?
It was stored already, yeah. In the second case, everything was available already through Fabege's data warehouse. So it was there, and then we got the historical prognosis and historical temperatures from SMHI, the agency. So that was easy.
Yep. Thank you. My questions may be a bit technical, but I was wondering why choose to retrain the model on all the new data and not instead use incremental learning? Like just train on the new data. I mean, there's probably some advantages. I'm generally asking the choice of.
Yeah, the model training is quite quick. So I guess we thought it's not really a problem. It takes probably less than a minute per property. So, but yeah, it's interesting with incremental learning. Do you have any tips on like good?
Not at all. I'm just asking for my own knowledge.
Yeah, no, it wasn't heavy enough that we thought we needed it.
I mean, it's not much data at all, so I don't think it would make sense. It's quite easy to just retrain them.
All right, thank you.
Can you do any transfer learning with it? Like if you train it on one building, could you transfer it to another building?
Yeah, we've so again there are 2 different cases here. So we have you have done some experiments with meeting room occupancy.
It was we have one model per room for the meeting. Like now we're talking about the meeting room occupancy, and didn't work that well. So, and the best, like you get the best accuracy, the better performance of the models if you like get data from one room and like train a lightweight XGBoost or something. We tried transfer learning with some transformer last year, but I mean it's not worth it because it's so much maintenance in a transformer. It's much larger. It didn't really make any sense, but it was a fun experiment.
Yeah, in the district heating case, we thought about it, but yeah, we only have 44 properties so far, and they are all quite individual. So yeah, it works well in this way, but if we get like several thousand, we probably need to go towards something like that.
And a unified model wouldn't work? Let's say maybe for 45 is not enough, but let's say if you had thousands, do you think you could have a unified meeting room model, that you could deploy?
Maybe.
Maybe.
Yeah.
I tried to put the meter key as a feature, so we have 40, like, I don't really remember the results of that experiment, but that would really make it easier to not maintain 40 models. Open-ended the answer. Yeah.
Yeah, Kaisa.
Hi, thank you for a really interesting presentation. I'm curious about the sustainability reporting that you mentioned in the end, if there are things that you will do with it, and if there's anything you can share on, I know it's obviously not something you've done yet, but the approach or what you're thinking. Because to me, it sounds like it's a really big case. If this is, you know, the case that you need to do this for, if you have over 200, 300 employees, then it's a big case for a lot of companies.
Can I start? I know, so since we're working at Fabege, and we have Fabege representatives here, so we have Vanja and Andreas, he's there. So they have a project called HEP, Hållbarhets energiprojekt, I don't know, but they're talking about this right now. Personally, I'm not really sure. Do you have, like, what's on the horizon? Yeah.
Yeah. Yeah.
Great, thank you.
Yeah, I think they are starting from taking a larger view at everything. I mean, AI is involved in some parts, but there are many other practical problems. So they're looking at it now, their committee, and then, I mean, we've done some small pilot things with the Microsoft Document AI, for example, that kind of works well for most of the documents. But then there's a lot that needs to be built around it for different kinds of reporting. It's everything from like flights to garbage disposal to, I don't know, everything.
I guess it's a lot about unifying data, really, rather than actually analyzing it. Yeah.
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 Okay, thank you.
All right, I think we'll take a break for 15 minutes, maybe 6:45, and then continue after that, right?
Mm.
Yep, cool.
Okay.
So if you have any questions, just feel free to reach to Mikael there. But yeah, thank you again for the presentations. Very good. All righty, we're gonna kick it off again. I should have mentioned this before. This is really bad of me, but basically we have emergency exit doors right behind you, and also the bathrooms are behind you as well. So there is like a little hallway, and then if you go to the right, there's bathrooms there. So just so you know. But yeah, I'm not gonna talk too much. I'll just say the next guest is Andreas from Fabege, and he'll now give you more of a context to what we're discussing here. So I think I'll just hand it over to you, Andreas.
Thank you, thank you. I hope I can do that then. Yes, my name is Andreas Hölne. I'm from Fabege, one of Stockholm's bigger real estate owners, and also the one that are working with Codon, with Mikael and Linus. And I'd like to start by just talking about AI and data and why we are working with these kind of questions, and maybe take you up to some kind of bird or helicopter perspective. And then we have Carl-Johan later from Myrspoven who can go down deep again. This is us, quite simple. We don't see Flemingsberg down there, but we are Stockholm based, one of the largest. We have 100 properties in Stockholm. I think you talked about 44, and that's because it's not buildings on all of these properties. Some is just grass and stone and stuff like that. And a total of 1.3 million square meters, so it's quite large. And this is our property value at the moment. I think we have a new report on Thursday, so that digits are for now. And if we look at Fabege, which makes us quite unique from a real estate company is that we are only in Stockholm. We are really close to our customers as well. So if you look at these areas, which are our business districts that we are working with, we also have our own offices in the same areas. So we are not far away from the properties, we are not far away from our customers, and it makes this kind of data-driven thing a bit special for us. We are not in need of having something that is really, really automated and so on, because we want to go out to our customers and have the relationship build out that kind of client relationship with them. And this is mainly what we do, and what we aim for when we talk about digitalization at Fabege. The ones down there, we talk about improve our internal processes, internal efficiency. We talk about reducing project operations and maintenance costs, and these are the ones that we have already discussed today a bit. I think it's at the moment or last year we did some things with to try to energy efficiency based on our data, and we have done a lot of cost savings thanks to Codon and thanks to a lot of other companies that are helping us. But the hard part is not the ones down there. The hard part is for us to work with our business districts and our clients, our customers, the ones that are working in the offices that we are building, that we are operating, so that we can have customers that wants to go into the office, wants to meet with each other, wants to build better companies, because that's what we think is the most important thing here. So we want to simplify our customers' life, everyday life. Want it to be easy to get to the office, want it to be easy to be in the office, everything should be nice and dandy, something like that. And that is also why we started with Codon. Actually, I think it's, I'm looking at Mikael now, 2 years ago, something like that. I was like thinking, okay, maybe we should look into this. We need some kind of data scientist, data engineer, someone who can try to figure out how we can use all this information. I think we have 4 million data points per hour that are stored in our data lake, or whatever you call it. But we had no structure in there. It was just a lot of information just adding up, and we didn't know what to do with it. We had some kind of idea. We should do something with it, but we didn't know what. So Mikael came in, and we started looking at this kind of how do we use our own office, starting to try to use the information that are already in the buildings, the data points that we already have, to be able to see how we can make the office better for us as employees, so we can also use that later to make our customers' offices better. So we always have the information about how are we using the office through the week or on a daily basis, what kind of areas do we like, so we can have the best office for every single client. And that's the main reason we are doing this. And we also have another of our friends here, partners in Farad, that has been helping us out as well. Because having maybe 70 or 80 real buildings, not properties then, but buildings, and being able to do this in one way with all the buildings, we wanted to be able to connect all those buildings. We wanted to be able to get the data out of all those buildings, and also be able to put data back to be able to steer the buildings in a smarter way, to save energy or to be able to make better services. So we have a standardized way in connecting the buildings and fetching all that information, because even if we are building new buildings today, and we put in new modern technology, we still have all those old buildings with old technology that needs to be operated as well. So it's not that we can just rip it all out and put millions of money or crowns in just changing the already existing technology in the buildings. So that's one thing that we needed to do. We needed to make it standardized. The other thing is that we have a lot of different buildings, and we have a lot of different service providers as well. And we need needed from our point of view to be able to change different service providers, change different things in the building with all the unique kind of technology or unique services that the building has. So therefore, we also needed to be flexible. Myrspoven is one of those examples that we have used this kind of technology and then being able to have a fully service provider coming in and controlling our building in a smarter way, instead of using smart consultants doing it for us. So we have the two kind of extremes here today, and I'm in the middle. And doing this, we hope that it will be scalable, that we can scale this through our property portfolio, and also working together with other friends in this in the real estate sector. We also want this to be able to be shared between each other. So if we build smart solutions for one of us, we can use that for another one. Because it's mainly the same kind of buildings, it's mainly the same kind of technology in all those buildings. Some are new, some are 20 years old, but we can still use it and be able to make this smarter together. And in that way, we get more sustainable as a real estate sector. We talked about this kind of district thinking. If we go into heating and we go into energy, we can help each other to do that better instead of each and every one of us doing it ourselves. Oh, this is mixed. This is a Mac, right? No problem. So the way we did this, we are trying now, we talk about this next generation digital platform. We are creating this central hub for our data. You have seen this picture in many ways from every company, I guess. And what we want to do is to be able to collect the information from our buildings, to collect the information from our partners, if it's Myrspoven or someone else. We want to be able to collect the information from our business systems and collect the information from the customers as well. So we can use that to build better buildings, but also build smarter and better services for our customers. We're looking at Wenner-Gren Center here, with one of the buildings we are owning that we are emptying at the moment to fix it up, modernize it, and we are looking into services that we try to make that like digital first from our customer perspective. So if you have employees starting at your company, they will hopefully have their key in their mobile phone the first day without being able to have some new app downloaded or something like that. If they're in the company catalog, they should be able to come into the office as well. So we're trying to kind of have that onboarding, offboarding experience that we have today, automated from the customer perspective as well to our kind of very fixed physical world. So those are kind of the goals that we are looking into. And as I said before, we are trying to both working with Codon and other consultancy firms as well. We have iQuest and Farad here. We have Myrspoven as well. So a lot of service providers that help us as well. And I think the best way, we talked about sharing this, I think the best way for us is to help these kind of companies to build better services that can be used with other real estate companies. So we can help each other to always get better at what we're doing. Because in our kind of sector, it's not the digital services that are the thing that makes people want to move into our house. It's probably the same as in a private part when you're buying an apartment or a house. It's location, location, locations. We can skip the war with our digital services. We can help each other out, and then we can have the fight over the locations. Thank you. Questions?
Yes, any questions?
I picked up for you now, Carl-Johan, right?
Yeah.
Yeah.
Are there any things that have been surprising to you, either that, okay, this has been much more complicated than we thought, or otherwise, on the other side, these have been much more easy to get done?
I'm not sure if anything have been easier. Absolutely more complicated. If we go into the scalable part, I think it's harder than we thought. It's harder than we have thought to get all this information from the buildings, to get that sorted out so we can understand it. I think if we look at our headquarters in Solna, we have something like 2,500 data points in just that building. And to being able to understand those from our data point of view, to be able to translate that into physical world and making smart things out of it, it's more complicated than we thought. And it takes time. And all this kind of, if we go into AI as one thing, all this kind of buzz that has been going on in that market, not helping at all. It's more or less that everybody wants this ChatGPT kind of solution, just like this. And from my point of view, the best thing to use that at the moment is small integrated services that are focused on one kind of problem, and stick to that for a couple of years maybe. And then we can have this kind of automated funny things that we put on top of that, but we're not there yet. So if you just let us work for a couple of years, then.
Decades. Oh, okay.
Any other questions? Yeah.
Hi, thank you for the presentation. I wonder if the majority of your clients have more of excitement about AI when you mention about like the buzz, or is it rather reluctancy precisely because of the hype?
I think they have the same kind of problem in many areas as well. They are also looking into AI from a company perspective, wants to do something with it. We are just a real estate company. It's not that we are in the what you call it, focus for them talking about AI. And if we look from our point of view as well, if we look at Carl-Johan services, it would be great to have those in most of our properties. But we have our own kind of core business that are part of what Carl-Johan is trying to change. So from our point of view, we have our own focus from AI perspective. We are focusing on managing the buildings in a smarter way. And if we look to our customers, I don't think they are going to look at Fabege for AI help or solutions or discussions. But we are going to open up our AI talks in our different districts to talk with our customers about it, because we have the same kind of problems. We have the same kind of strategic questions about it. And we have a lot of great companies that are sitting in our buildings. So to use that force to be able to make it better together.
Anyone else? No?
Have I horsed you enough now?
No, but I think I can add to that. Like today, working with several real estate owners, it's very specific use cases when it comes to AI. Like workspace management or optimization is one, and then we have energy optimization is another. Like give it a few years, and I believe that those two will work much more together, so that we know about how the workspaces are used, and then we can control the energy usage much more based on that. But where we are today, it's very like specific in all the applications used by the real estate owners.
Yeah.
But still early in the development of AI solutions, I would say.
Cool. And with that, thank you, Andreas. Thank you so much. So, round of applause. And the floor is yours, Carl-Johan.
Yes, thank you.
So we have Carl-Johan from Myrspoven now.
Okay, so I will try to put a specific use case to this. Oh, yeah, thanks. Working with computers and internet. So. Oh. Thank you. I'll just, yeah, it looks okay. Okay, so my name is, sorry. Trying to hide that bottom. Bottom. Okay, it's then Zoom. Yeah, it's a picture of me behind that box. So I'm from Myrspoven. My name is Carl-Johan. I'm actually working with partnerships within Myrspoven, but I have a technical background. So I will try to put a bit of a technical perspective into how we work with energy optimization within buildings using AI. Just to give you a brief introduction to Myrspoven, we are working with several of Andreas' real estate colleagues in the sector. And we are running around 4 million square meters as today in around 1,500 buildings and running projects in 9 countries. And I will let you know a bit more on what we do. But first, I will try to give you a bit of a perspective to where the real estate business is right now and why AI is interesting in terms of energy optimization. And of course, then why AI. As a real estate owner, you are facing a few challenges right now. One is that we have a lot of buildings that will be still standing in 25 years from now. 2050 forecast says that 2/3 of all buildings will still be used, and by that we need to retrofit and upgrade the buildings that we have. We can't fully rely on new buildings. Buildings are also big in their greenhouse gas emissions. Looking globally, around 30% of the total CO2 emissions comes from building operations, not only construction. If you add construction, you have an even higher percentage. At the same time, you have a lot of new legislation coming in, especially from the EU, putting pressure on building owners. In a Swedish perspective, this is still being processed, but it looks like the worst performing buildings in the real estate portfolio as a whole need to improve a lot. And if you don't, you will have stranded assets. So there are discussions on how you will be limited in how you can rent out spaces and how you can utilize them as an asset. So legislation is super important, as well as increased costs for energy. I think everyone in here have heard about the energy crisis and the costs that comes with it. And finally, we have a need for more energy and a higher flexibility within our energy systems, because the power that we have today will not be enough in a few years' time. Our take on this is to work with how buildings are operated and how they consume energy, both in terms of energy usage, but also in terms of flexibility. So when in time are the buildings using energy? And the process, of course, could be boring, but we need to do an integration into the buildings. That's what you mentioned, and you have at Fabege like middle data layer, iQuest, which kind of connects and harmonizes all the buildings to one same interface. Following the integration, we take control of the building. So we actually start to adjust and change settings in HVAC systems, so heating, ventilation, and cooling. And by that, we can achieve a reduction in energy consumption. And finally, we need to generate some insights and reports on how we are actually performing and how the buildings are doing. So going even a bit more into detail, like connecting to the building and gathering the data from the building is super important, both in the control system of the building. So take this one as an example. You have technicians every day logging into an interface where they can see the heating systems, the ventilation units, etc., on like a specific human machine interface where they can adjust a lot of settings to achieve the indoor climate that they want with as lowest energy usage as possible. And that's the system that we connect to gather all the data. We have, of course, measurement of the indoor climate so that we actually know if we are keeping a good indoor climate. That's super important. We let that data stream into our data set together with a lot of external data. External data for us is weather forecasts. And we are using, I think, 12 different weather situations. So solar radiation, rain, cloud coverage, etc., but also social data. And for us, social data is not measuring how many people that are in the building. It's rather a reference frame for how behavioral patterns are looking in the building. So it could be calendars, it's time during day, it's typical holiday calendars, etc. A lot of things that helps the system understand why we got certain behaviors in the building and certain patterns in the building. This is when we have all the data streams in place, where we start generating a kind of basis for the model. So we don't do any manual data labeling. We are letting the system gather a lot of data, and over typically a 30-day period, we are starting to build correlations in how things are impacting each other. So sensors measuring temperature in the indoor climate will have a strong correlation to solar radiation if they are on the southern facade. Sensors on a certain floor will have a strong correlation to the air handling units ventilating that specific floor, and so on. And this training is done every night, so we're getting a better and better model for every day that we collect data. So for us, that digital building clone is just a big like matrix of correlations, which is physics-based informed. So we are using physics and thermodynamics of buildings in order to understand how to run them the most efficient. And from that model, we're using both real-time data to be reactive, but proactively also running an optimization every 15 minutes, calculating what's the optimal set point for all the technical systems in the building right now, given what we see in real-time data, but also what we know in thermal capacity, behavioral patterns, weather forecasts, everything that will impact the building over the next 48 hours. And by that, we can start utilizing that free energy that we are generating now by being, I don't know, 100 people in here, we generate a lot of heat, and by that we can take down the heating added externally. And then we are writing those calculated set points into that control system every 50 minutes so that we can run the building as efficient as possible. And what we want to achieve on a high level is that we want to move away from a very static approach to how you run buildings, where you kind of get what you get. The systems aren't that dynamic, so you can't really adjust them as much as you would like. And of course, you can do it every 15 minutes as a technician. Maybe you adjust the settings once a month or so, and then in between they're calculating on a few set data points. So moving away from kind of sub-optimization to a more streamlined and dynamic way of running the buildings, where we don't run them more than needed, so to say. So if we are 10 people, we can ventilate on a certain level. If we're 100 people, we need to ventilate more. Very difficult to talk about general savings, but of course we save energy. And looking into the Fabege project, this was a screen dump that I took earlier today. Here we can see what we call AI versus baseline. So the gray line you see, that's the original control set points. So this is for heating. So that is typically like a negative correlation to outside temperature. When it's cold outside, you heat a lot, and when it's warmer outside, you heat less. But in the blue line, we see it's very much more dynamic in how we have optimized the heating in this building. And this certain point that I've chosen is lunchtime, 1st of February, where we might have a lot of people in the building, adding a lot of free heating, like with the body temperatures, and by that we can take down the external added heat, but still maintaining 21 degrees inside. Ventilation, same thing. Typically you're running a building by turning on the ventilation in the early morning, pang, 100%, run it to the evening, turn it off. No matter whether it's 0 people or 100 people in the building. Whilst we are, with the blue line, controlling the airflow in the building according to the need for ventilation. And looking at the performance numbers here, we can see that we are actually decreasing the usage of energy in this building quite a lot. This is not to be seen as energy per se. It's like numbers for set points. We can see that we're lowering the need for externally added energy. But what else? I mean, now we're looked into building. It's a good way of saving energy, of course. But what you mentioned, Andreas, working as a collective, like group of building owners for the greater good, we can also look into society. And now these have changed color, but blue is nice. This is a few icons I've chosen to try to symbolize, to make a visualization of society and the energy system as a whole. We have consumers, we have some production units, nuclear, it's a lot of talk about nuclear, and then we have a distribution network on the right side. What's special about an energy system is that you need to have production and consumption in perfect balance all the time. So if we turn off the light here, you can lower the production, or you need to lower the production in the same amount. But now, as we are getting more consumers, like Northvolt factories, hopefully starting for real soon, we got more energy production that is more difficult to plan. We got a bit of a situation where we're moving towards a situation where we don't have production and consumption in perfect balance. And of course, working with the production side is one alternative. Nuclear is the answer to all questions, if you ask the politicians, but we believe that flexibility can also be a good way of getting there. So working with your demand for energy and power, that could be done by batteries, but if you ask us, that could also be done by controlling the buildings. Because every building has a lot of thermal energy stored in like the temperature of this chair, in the temperature of that roof. All the building materials in here is 21 degrees. So if we turn off the heating for a few hours, it will still keep an indoor temperature of 21 degrees. So we can be very, very flexible in how we use energy within buildings without impacting the indoor climate very much. And by that, you can look at the peak loads in an energy system. And this is quite standard profile for how building is using energy over 2 days. The first day is a bit warmer, so it's not using as much energy, but the second day is colder, and then it's increasing its energy usage. But then during nighttime, we have quite a low energy consumption, which is, like from a system perspective, not as good. So if we instead can take away a bit of the peak load on the second day and put that during nighttime, we can work with thermal capacity in the building and preheat it. So it's maybe a bit warmer in the morning, but we have enough energy stored in the morning to keep a lower energy consumption over the day. And this is actually something that is like being pressed and promoted from the EU as one part, but in general from the different parties within the energy ecosystem. And looking into Sweden, we are already quite far ahead in those demand-side flexibility markets, where we can work with different type of flexible resources. Buildings is one. Charging networks for EV vehicles or electric vehicles could be one. Installed batteries is another. It's a lot of different flexible resources that can help out in lowering the demand from the energy system. And this is, of course, something that you as a building owner want to have some kind of payment for. And that's where we see different flexibility markets popping up. So if you look to Gothenburg, Göteborg Energi have something they call Effekthandel Väst. In Stockholm, we have had something called Stockholm Flex. And what those markets are doing is that the energy providers, they look into their predicted need for energy and power to distribute to the consumers. And at some point they see, okay, now we will have a constraint in the network. We need to either increase our supply of power or lower the demand for power. And that could be done by these flexible resources. So you will have a situation where a company like Stockholm Exergi are sending requests or like a control signal asking an aggregator like Myrspoven or any other to use their flexible resources in the best way to locally optimize the energy system. And for us, that could be that we take away the demand for power in some buildings over a few hours' time. And by that, building owner like Fabege can be paid by Stockholm XG, who doesn't need to expand their network or produce that last very expensive piece of energy. So we believe that by using AI for controlling buildings, we can have a lot of cool slides moving away from me, but we can also solve all the problems that we see within the real estate sector. So dynamic control is really a good way of getting there and creating a lot of value for building owners. That's all. Thank you.
Thank you very much. Really cool. I love the integration of physics into anything. So I'm a big fan. Yeah.
And no tough questions about learning models and trainings.
You briefly mentioned it, but how can you retrofit the buildings to be able to provide all that data you need?
That's the control system that are installed in at least all bigger buildings. So it's like a human-machine interface where you can log in as a technician and adjust different settings in a digital view, and we kind of override that digital system. So you have controllers installed all over the building, connected to the air handling, connected to the heating system. And in those controllers, you have set points, as it's called, like settings, which we override and control instead of the technician doing it.
Hey, Carl-Johan. Mikael Demadis, Einar Mattsson. We are having some really interesting project together at KTH, Royal Institute of Technology. So my question is, Einar Mattsson is a residential real estate company here in Stockholm. My question to you and pretty much all the AI and prop tech is, how can we as a real estate company install less sensors and get enough data and the right analysis from less sensors in the future?
And are you looking to the indoor climate sensors? I would say that sometimes there is a overbelief in how many sensors you need. We are typically saying that one sensor per 250 square meters is enough, because that can demonstrate the overall indoor climate in the building. But of course, it comes down to how granular you want to be as a real estate owner and how much risk you're willing to take in not covering every corner within the building. But we are in shopping malls here in Sweden. I think we have one sensor per 850 square meters, because that's enough to understand the overall indoor climate in that building. So it varies a bit from what kind of building it is. I mean, in this space, I would say, I don't know how many square meters could it be? 200? But yeah, something like that. Like one sensor could be quite a good representation of the indoor climate in here. Yeah, yeah, I guess so. Yeah, yeah. So
nice. Yes.
So I really like the idea of flexibility, not just on the production side, but on the demand side, which you guys are working on. Do you have any numbers, either in percentages or like SEK per square meter, in terms of how much you can actually expect to earn if you're active in these different flexibility markets?
I would say that's maybe the biggest challenge of these flexibility markets still. They are so young and immature, so the pricing models haven't really found its way there. I don't know if you have any experience of the flexibility. Yeah. Yeah. And I would say you can have two kinds of monetary value creation. Either you participate in a ordinary flexibility market, you get a bid and you respond to that and you get paid, or you optimize towards pricing tariff, or the spot price on the energy market, electricity market. If you have a heat pump, you can preheat when the energy or the electricity price is low during nighttime, and then you can lower your demand for heating over daytime. So there are different like optimization targets that can be used.
Do you see any issues with the fluctuating climate right now, going from different extremes, from cold to warm?
For us, that's actually good.
That's good. Okay.
Yeah. So like spring and autumn is our like peak seasons, because if it's a cold day, minus 20 degrees, you need full heating anyway. So then we can't optimize much. But if we have those variations, that's sweet spot.
Okay. So more climate change.
Yeah, more climate change,
Okay.
please.
Right. Nice.
So digging our own grave here. Saving energy.
Thank you for the presentation. Really cool idea with this flexibility and preheating of the properties or buildings. But I wonder how that can impact the experience of being in the buildings.
Yeah.
Like, how does that impact the inhabitants? Do you notice it being too warm in the morning and cold in the evening? Do you have any data or knowledge about that?
So typically when we work with flexibility, we ask the building owner to give us a number on how much variations they accept in the indoor climate. So of course, if you have like a target temperature of 21 degrees and you're okay with differentiating half a degree both ends, that will take away some of the potential for flexibility if you compare it to differentiating 1 degree, either up or down. But in general, you don't need to change the indoor climate very, very much to store quite a lot of energy. So I mean, if we would heat this building half a degree warmer than it normally is, that will consume quite a lot of energy. And by that, we have also stored quite a lot of energy by doing so. So with the thermal capacity that you have in most buildings, at least, even half a degree can help a lot.
Thanks.
Thank you for the presentation. I wonder if you can tell us a little bit more about how the solution works to identify the correlations between the different sensors and sources of data that you're using. Are you using AI for that, or is it more the traditional statistics?
We're using AI. I'm not an AI expert myself, but it's like a regression based model. I don't know if Cindy tells you anything in here. Anyone? It's like a standard model for regression based calculations. So I would need one of my colleagues to answer that in detail. But I take their word for it. So.
Thank you.
Yeah.
I think that's it. So another round of applause to, thank you.
Yeah, thank you very much.
Thank you, Carl-Johan. And yeah, I'd like to thank you all for coming. So we are going to release this on YouTube, all the recordings here, so you can have a look at it later. And yeah, we'll try to get the slides if it's okay. We can share it in a Slack. If you become a member, you can get access to that. So yes, thank you so much. Have a lovely evening.